IGCSE Computer Science, Syllabus Statement 1.3.5F, and this video is going to be quite chill. So, calculate the storage requirement of a file. As said in the previous video, actually, my room's gotten dark. Give me a second. I'm just going to turn my lights on. Anyway, I'm going to walk and talk. Anyway, so, I said anyway a lot. Okay, so, text files. So, we're looking at the storage requirement of two types of files. We're going to be looking at text files and, image files. Yeah, that's it. Anyway, so let's look at a text file. So we have a text file here saying calculate the size of this file. So here's how we can do it. So if you remember, 31 characters. This is 31 characters including the spaces. Each ASCII character has a value of 1 byte. So would the file be 31 bytes? Well, let's have a look. Ooh, size 31 bytes. So yeah, that's true. It worked. Yay. That's pretty much, yeah. I know it says 4 KB on disk, and it's because there's a lot of other code involved in this, but we're not concerned about that. We're concerned about the actual size of the file. Image files. So here we have, kittens. We have 4 little kittens here. And this is a BMP image file. So this image is 1600 by 1200 pixels. Now if you remember, we do this. So 1600 times 1200 times 3, which gives 5,760,000 something like that bytes. So would the file be that many bytes? I'm just going to check if I did my calculation right. 1,000 times 3. I hope it's right. Don't want to scrap this video. Yeah, it is. Alright, so would this file be this many bytes? Well, let's have a look. And again, this is a BMP image, which I called cat.bmp. And as you can see, 5,760,138 bytes. So close enough. And again, the size may vary due to other code. So, yeah, we're pretty much close enough. So you get the idea, right? So if they ask you a question like that in the exam, estimate the file size of this, then you can do that. Alright, so let's try a question. So text is to be stored in a document. So I got this quote from Mark Zuckerberg. Calculate the file size required to store this document. So what you do is count the number of characters in the sentence. So the text has 109 characters. Each character is 1 byte. So the file size should be 109 bytes. Let's try an image file. So an image question. So a BMP photo is 1024 by 512 pixels. Calculate the file size of this image in megabytes. Sometimes they ask you to convert to megabytes if your answer is in bytes. And they do that quite frequently. Now here's the thing. You're not allowed a calculator on the exam. And if you're really, unless you're really, really good at math, it's going to be pretty hard to actually convert from bytes to kilobytes to megabytes and so on. So like dividing by 1024 can be quite hard. Now, the good news is, I had a look at the mark schemes for all the papers, and it says that it's totally fine to divide or multiply by 1,000 to convert. Yay! We're saved. All the people who are really terrible at math are saved. Alright, so, we're not going to be doing that in the video, though, because we want to be true. But you know, if you really can't convert using 1024, you could just do 1,000. Like that's what I'm going to do, because I cannot, for the life of me, cannot divide any number by 1024. I can do 1,000 because it's just moving the decimal, but 1,024, nope. All right. So it's 1,024 times 512 times 3, and remember the times 3 is from the colors, RGB, and that gives us 1,572,864 bytes. Converted into kilobytes, so we divide by 1,024, that gives us this, divide that by 1,024, and that gives us 1.5 megabytes. So I'm just going to throw in a random question here. It's not really random, it's good for your learning. We're going to throw in a JPEG compression question. So this file goes through JPEG compression, and it's compressed by a factor of 12. Oh yeah, if any of my calculations here are wrong, then just, I don't know, post a comment or something, and then I can use annotations to edit it. Anyway, it's compressed by a factor of 12. Calculate the new file size of this image in kilobytes. So you got to be careful when they say in this many or this in this this unit, because what I wouldn't say most people, because I don't know if people do this, but what people could do is they don't read the question properly, so they say, oh, okay, let's compress this by a factor of 12. There, this is the answer in megabytes. But no, you have to be careful to what they say, and it will follow what they say. So let's convert it to kilobytes right now. So 1.5 megabytes that we had last time times 1,024 gives us 1,536 kilobytes again. Then we can compress it by a factor of 12 by dividing it by 12, and we get 128 kilobytes. Nice.